Welcome to Big Data on Brews, today with Ron Bodkin.
Nice to be here.
Think Big Analytics. Can you introduce yourself and the lovely brew you brought with you?
Certainly, Stefan. So we started Think Big just about 4 years ago, always with an exclusive focus on helping enterprise customers take advantage of big data. I came to that because previously I had been VP of engineering of a pioneer in this space called Quantcast. So at Quantcast, the initial mission was to measure the internet, and with Nielsen and ComScore were saying the only way you could measure internet properties and advertising campaigns was with small samples, and we proved you could directly measure the internet, and that quickly led us to using Hadoop. We put it in production in 2006 and went on to build a fast-growing lookalike business model to find millions of people like those who buy goods and services online using Hadoop. And we built our own NoSQL technology because there was nothing commercially viable when we were starting to look in 2007, and distributed data science. So out of the chance I had to lead the teams that did that, I realized it was a great opportunity to bring the band back together and pull together some of the veterans from a company I was the founding CTO of in the 90s called Seabridge, which was internet services, helping the enterprise take advantage of that technology trend. So the other founders of Think Big, Rick and Katie, were senior people. Rick, the first senior hire at Seabridge, and we recruited other veterans along the way, and started working with a couple of companies. PayPal, actually at the time was Ware, and it got acquired into PayPal, so it was hyper-local advertising and place recommendations. We helped them build their data platform and data science. And shared customer, Charles Schwab, helping them with CRM, using Hadoop to analyze their customer log data. So we were off and running back in 2010, and here we are 4 years later, over 70 people, and now having worked with a number of fantastic enterprises with really three main focus areas: customer analytics, using clickstream and other data sets to really drive effective understanding of the customer and go beyond siloed applications; financial fraud analytics, helping understand fraud and risk in financial scenarios, especially consumer-facing; and then high-tech manufacturing, device data, and manufacturing data sets. So we bring deep expertise in the engineering and data science required to deliver great outcomes with big data.
Let's talk about the brew before we go into the details.
So I'm a big fan of hoppy beers. I love IPAs.
Okay.
I couldn't resist because there's a few really fun beers. I thought we might get in trouble if I brought you a bottle of Hoppy Ending. So you'll have to look that one up on the internet. But Stoopid's another great choice. It also comes in a convenient shareable bottle. It's a local brewery, Lagunitas.
Okay.
We're talking about beforehand that it's served in the German style because I picked it up this morning and drove around to meetings. So it's now served, I would call it cowboy cold. You might call it German, the proper German temperature.
Yeah, don't cold beer too much because the flavor goes away.
It's a little bit like white wine. We were tasting white wines and struck by serving it at a warmer temperature that it's a much nicer taste. You really can actually taste it instead of it being so cold, it suppresses the flavor.
Let's see, I'm usually not a big fan of hoppy beers, but at least you can see through this one. That's good.
Cheers.
Cheers.
What do you think?
It's good. It's not. It's a smooth hoppiness. It's not as like. It hits you in the face.
It's not like Torpedo IPA, slap in the face.
And you have to wiggle with the ears. It's good. I like it.
Glad you like it.
Cheers.
Cheers.
Yeah, that's okay.
As we were talking about the history with Think Big, we very early on, you and I met each other, I think it was at a Hadoop meetup back in 2010 when Datamir was inside a shoebox, and Think Big, we didn't yet have an office. And I remember us getting together and starting to talk about the opportunities around big data and what customers needed with Hadoop.
Yeah. So you talked a little bit about Quantcast. I really want to dive into that, right? So if I remember correctly, the first cluster you guys deployed was actually still Nudge, and then you built your own, you extracted the MapReduce out of there. It was before it was even called Hadoop. Right.
So it was definitely MapReduce and HDFS were still part of the Nudge project when we deployed it in production in 2006. And really the seminal moment was and here I'm really saying Paul Sutter, who's the co-founder and president, he had worked at Alta Vista, so he understood how you built a large-scale custom application to deal with data at this scale. But he had recommended by Mike Oceanikoff, who'd worked with him before, to read the MapReduce paper by Google. And the thing that really was compelling about that was that the number of programs that people checked into source control at Google using MapReduce just grew exponentially. It totally worked as a general purpose programming paradigm that solved a lot of interesting problems, even though it was a simpler programming model that meant you could actually build a common system to support it. So that convinced us that it was worth going with MapReduce instead of a custom system to do the distributed sort merge for doing audience measurement. And the result of that was that we discovered that the Nutch project had what became Hadoop inside of it and ran with it. And as part of that, we had to do a lot of our own engineering work around Hadoop. Unlike Yahoo, who was another early customer and could afford thousands of nodes and cared mostly about reliability, we had to make it work on a startup's budget, and so we had to tune the efficiency and tune the sorting algorithm. So we did a lot to evolve it, and made our own modifications to make it work well for our needs and our own programming layer on top.
Didn't you guys at some point even run the second file system in parallel?
That's right.
Kiwi, what was it? I forgot.
It was KFS. That evolved into what's now QFS, Quantcast file system. So the big reason for running two file systems was the concern around the possibility of data being lost through bugs. So by having a second file system in the cluster that was read-only, write once and then read, it meant that we could back up critical data sets in a way that they weren't likely to be damaged. And if there ever were a bug in the file system code that would corrupt data, it would ensure that we'd have a copy of that in another file system and not lose it permanently.
Right. Yeah.
I mean, obviously HDFS has matured a lot since then. And so the concern around there being a bug in HDFS that eats data is a lot less than it would have been back in 2007, 2006, right? So things have evolved. But
yeah, my favorite one was always when you saw those posting in the email list, is there an undelete for HDFS? Because someone typed in HDFS client remove /space. Oh, I did a space after the slash.
Oh yeah.
Yeah.
That indeed, that's the big reason why we had a write once file system is the number one cause of data deletion in the history of Quantcast was user error. Yeah. People inadvertently, recursively deleting things, right? So as you say, so having a backup is important, but if you have a backup where you have mirroring, where you just mirror the delete command into your backup, it doesn't help you, right?
No, yeah. So that's really early. How much data, how big was your infrastructure at this point? I think you guys, back then I remember it was just mind-goggling, big, ginormous. Today we all like, it's not that big anymore. But back then it was quite impressive.
So, Quantcast went through a series of clusters. In the early years, probably every 15 months, we upgraded to a new physical cluster, and the clusters grew not only in the number of machines, but the networking and the scale of the equipment. So, the biggest cluster that we actually kept for a longer period of time and kept extending started out with several petabytes of capability.
And that's 2007.
So we put that one in place. It went live, if I remember right, in 2008.
Okay.
Right? So earlier than that, we'd had a smaller cluster. But we had, overall, we grew it to, we thought about it in terms of the number of cores, and we did our own scheduling where we had lanes, which were collections of separate sets of nodes that would be scheduled independently. We found that trying to have jobs coexist on the same machines didn't work very well for us, so we split it out into kind of a set of virtual clusters on the same hardware. But there we had a few thousand machines, each reasonably dense storage. Back then you didn't have 2 terabyte drives, weren't even common. It was like terabyte drives. Yeah. But so we ended up having then several petabytes of storage and pretty significant capacity. We had the ability to sort routinely 100 terabytes of data.
What was the biggest challenges, especially in the early days? I think at some point you guys got drifted quite off of the nudge master or trunk, as we call it in this SVN.
Yeah.
So what was the main things you guys fixed in your version?
So, early on, what we did a number of releases where we resynced up with what became Hadoop, and would forklift our changes in. I mean, we put some hooks in to give us better visibility into what was going on in the jobs. We built a higher level programming API for making it easier to program MapReduce jobs. Still in Java, but more of a data binding approach. And we invested in, of course, second file system and integration of that, as we talked about. And then the other piece that we put a lot of effort into was tuning efficiency, especially sort efficiency. We had big jobs that routinely sorted large amounts of data. And even today, the sorter in Hadoop is not optimized in the way it could be. So we made a number of changes. I don't think I'm allowed to talk about exactly what we did, but we made a number of modifications and improvements to drive better sort performance.
Now, there's this fun little story where this really small startup came to you guys. I think it's called Facebook back then. Yeah,
that's right.
And I think Peter Thiel introduced the Facebook data team, Hammerbacher and Co. to you, and they came by. They did like a visit.
That's right.
And like, what is this thing here? This is incredible slow. It's in Java. We all in C++. What happened there?
Yeah, so they had tried out Hadoop and had found that running it out of the box, they were getting worse performance on a cluster of machines than they could get doing the same thing with a single program,
right.
Word count and so forth.
Right.
And so instead we showed them what we had done to make Hadoop work well and get meaningful scalability and great results. And it was pretty important in them deciding to embrace Hadoop because they're considering MPP database alternative at the time, and convinced them that embracing Hadoop and contributing to that would be a better choice.
And I think now they're kind of by far the biggest Hadoop user out there.
Yeah, they have the biggest Hadoop cluster. We've been doing some work with them on that cluster.
Yeah.
So
it came all the way back.
That's right. Been able to help them out.
Yeah. So you showed them Hadoop, and you still have to help them with Hadoop.
That's right. The thing that's so exciting is that as organizations take advantage of Hadoop and big data, that there's so much value to be created that there's immense opportunity, right? That companies see so many ways they can use analytics and drive more results that even a company like Facebook that has a very deep set of capabilities still looks for outside help because they have so much they want to do and there's such a need for expert help like we can provide.
Yeah. So that leads us into your customers and what is it, what you really do at the customer. So what I heard you saying is kind of you build big data applications, but where does it start? Where does it end? And, what are the challenges as you go to that journey with customers?
Sure. So, really, we want to help customers be successful through the life cycle of big data adoption. And that often starts with a strategy and roadmap, helping bring the technology and business teams together and understand what are the low-hanging fruit first opportunities for starting to get value out of this technology. What's a sequence of build out of technological capabilities to get to a goal architecture? How do you develop the organization, create the right center of excellence and competency? So we help customers plan out for success and then execute in an implementation program where we'll integrate best-in-class platforms and tools. We bring some of our own packaged components that make it faster and easier to get results and really assemble solutions that can start to give real business insight, right? So we see customers need help in a range of areas that typically we see a lot of organizations that have tried out, done a lot of proofs of concept of various technologies, but have not yet. There's so many options out there, and it's not always clear that sometimes vendors position technologies that aren't best for everything, as a fully general solution, right? So we help customers understand what are the real best uses, how do you integrate these things, and how do you get an agile approach of starting to deploy capability in a test and learn fashion, right?
Is the profile of the companies and organizations you work with rather kind of fast-moving startups or big companies trying to really get their feet wet with big data?
So we work with a range. I'd say that we do a lot of work with larger established organizations that have enterprise assets, that they often have a lot more to think about in adopting big data, that it's not tabula rasa. They have to think about governance and regulatory constraints and how to integrate with existing data processing analytic systems. And yet at the same time, they recognize that their industries are being impacted by the deluge of data, the ability to be smarter, and competitors often, startup competitors are using big data to change the conversation, to build engagement with customers, to build new offerings. And so established players in industries are needing to respond by investing in big data solutions of their own.
In those larger organizations, is it more a technology challenge, especially maybe around integration, what I just heard? Or is there very frequently more social challenge? You talked about the center of excellence. Where do you see really, some of the roadblocks?
Well, I think there's challenges in both, right? I mean, I think often organizations make the mistake of assuming that this technology is a small incremental change to what they're currently doing. It's so overplayed, the statement that this is a paradigm shift. Some technology that people are using is going to change everything. And so, not surprisingly, most organizations, most IT departments are skeptical of that and assume that that's fine. We'll send somebody to training. A couple of weeks later, they'll now be experts, and we'll be able to build our own big data solutions, right? So there's
and then they fail.
And maybe they rely on legacy services firms that have abandoned the ability to do software engineering a long time ago and now configure packages, but tell them that they know how to use big data. And they can put together a whiteboard and a PowerPoint, but when it comes to actually implementing the system, they don't know the patterns, they don't know how to make it successful.
Yeah. Is that, especially Hadoop seems to be, as an open source platform, very complicated, right? I mean, the technology idea was very simple, but then all the configuration, all the knobs you can turn on, is that a challenge that a lot of people are running into?
Yeah, I think that, there's a range of complexity, everything from how do you work with data in the environment? How do you build applications that are robust? What are the patterns for data modeling, as well as how do you administer and operate and manage a production application, as well as how to integrate with existing systems. All of these are new patterns and are complicated. And it's fair to say that enterprise data infrastructure has always been fairly complicated, right? If you think about a really well-established database like Oracle, you still expect in any organization that's running Oracle a whole cadre of experts, database administrators, who are dedicated to the care and feeding and keeping that system up and reliable, right? So there's a lot of complexity in managing data systems, and that's a technology that's got unbelievable amount of investment, both in terms of human hours from consumers, customers of it, as well as investment by one of the largest software companies in the world.
Where do you guys start? And where are companies that selling Hadoop distributions end?
Well, I think that there's a very different emphasis in our business models where we're emphasizing developing strategic applications for customers that really create unique differentiation for them, right? So how do you blend together data sets, break down silos, and start to drive business outcomes? Whereas the Hadoop distribution vendors are really focused on driving a platform business and subscription revenues around that. As one of our customers said, we like that there's a bit of overlap in services between our distribution vendor and Think Big, because if there weren't an overlap, there'd be a gap. Right. So we want to make sure that we've got things covered, but we like to use our distribution vendor for days of expert services to certify things for basic cluster configuration. And when it comes to actually doing the heavy lifting of the integration, the application architecture, we want a vendor neutral expert that knows how to assemble the right pieces together and deliver outcomes.
Yeah, great. Well, thank you very much.
See you
in the next episode, and let's have a little bit more
Hop Stoopid.
Hop Stoopid. Jeez, that's good.
Cheers.